everyone, hope you all are safe at home. Welcome to DSF online classes. I am Supriya. Today we are going to learn in this video about what is motion. So what is motion? You will be thinking about some moving objects or things which are in motion, right? But what is the correct definition of motion? Motion is change in position of any object with respect to time. When we say change in position, that is with reference point, meaning change in position is always referred with a reference point. For example, when we say Earth is rotating or revolving around the Sun, here Sun is the reference point for Earth. Similarly, with the next example, for a moving train, the box is at rest when the person or a passenger sitting in the train, the box is at rest. So for the moving train, the reference point is the passenger and the train. For a person standing on the platform, the reference point is the platform. For him, the box is in motion. So these are the two examples of a reference point, meaning there is change in position with respect to a time is called motion, and referring to a point is called a reference point. When we come for what is quantities, there is a physical quantity which shows a physical property which is used for measuring and calculating. Standards for measuring and calculating any physical quantities are called as units. In physics, we use measurements for calculation. So we use SI units. SI unit is internationally standardized units for measuring things. For example, mass is expressed in terms of kg. Length is expressed in terms of meter. So quantities are divided into scalar and vector quantities. Scalar is a physical quantity which shows only magnitude. Magnitude is numerical value. Scalar quantities are defined as physical quantity that has only magnitude, meaning a numerical value. For example, mass, length, distance and time. Example for a scalar quantity. Distance. When a person is traveling from A to B, say he is covered 5 miles. So, a quantity, a numerical value is determined. So, whichever shows a numerical value, such quantities are called as scalar quantity, which shows a numerical value. That is, it has only magnitude. Coming to vector quantities. Vector quantity is also a physical quantity which has both magnitude as well as direction. For example, force. Force has both magnitude as well as direction. When I say a force of 50 Newton, force of 50 Newton traveling 30 degree. So here scalar quantity which is 50 newtons and direction 30 degree is determined. So whichever has both magnitude and example, we saw distance. For vector example, we saw force, which has both magnitude and direction as well. So next we will study about what is distance and displacement. So what is distance? Distance is the path length or length of the path of an object. Say the object is traveling from A to B. So the distance covered will be from A to B. So A is the initial position and B is the final position of the object. So the definition of distance is defined as the path length or length of the path of an object. A is the initial and B is the final position. So distance is path length from initial point to the final point is called as distance. Next, what is displacement? Displacement is the shortest path between the initial position and the final position. When we say, for example, the student is traveling from home to school. And from school to park. And then back to home. So here, this is the initial position. And final position also, it is home. Here, the displacement becomes 0 because the initial position and the final position was home. So the displacement becomes 0. The definition of displacement is the shortest path from initial position to a final position. When we take another example, the car starts from A initial position and goes to C, then D, then it comes to B. So this entire path is called as distance. But displacement is called as the shortest path taken from initial position to final position. So here the shortest path is from A to B directly, but distance covered was from A to C, C to D and then to B. So distance is the total path length covered by an object is called distance, but displacement is the shortest path from initial position to the final position. Let's solve a problem on distance and displacement. The first problem, a car moving along in a straight highway from point P to point Q to point R and to point S, then back to point Q and finally to the point R as shown in the figure. From point P to Q, it is traveled 3 kilometers. From Q to R, 5 kilometers. Then from R to S, 7 kilometers. Then from S to Q, 7 plus 5, which is 12 kilometers. Then finally to point R. So from Q to R, 5 kilometers. Let us write what is given. So from P to Q, it is 3 kilometers. From Q to R, 5 kilometers. From R to S, 7 kilometers. Then from S to Q. So from S to Q it is S to R 7 plus R to S 5, which is equal to 12 kilometers. Then finally to point R. So from Q to R it is 5 kilometers. So first let us solve distance traveled by the car. So the total distance traveled by the car is PQ plus QR plus RS plus SQ plus QR. So 5, 3 plus 5 plus RS 7, SQ 12 plus QR 5. So 3 plus 5, 8, 8 plus 7, 15, 15 plus 12, 27 plus 5. So 32 kilometers. So the total distance traveled by the car is 32 kilometers. Next, let us find the displacement of the car. So what is displacement? I told. Shortest distance traveled from initial position to final position. So our initial point was P and final point is R. So P to R it is P to Q is 3 plus Q to R is 5. So 8 kilometers. Okay children, I hope you understood the problem. Let us go through a quick recap. Distance traveled by the car is from PQ, it is traveled 3 kilometers. From Q to R 5 kilometers. From R to S 7 kilometers. From S to R 7 plus 5, 12. 12 kilometers, and from Q to R 5 kilometers. So the total distance traveled is 32 kilometers. Displacement of the car. What is displacement? The shortest distance traveled from initial position to the final position. So initial point is P, final point is R. So from P to R it is P to Q is 3, from Q to R is 5. So 3 plus 5, 8 kilometers. I hope you understood. Let us move on to the next problem. An object moves from point A to point B and then to point C. Here we have to find the distance covered by the moving object and find the magnitude of the displacement of the object. So here, what is the distance? Distance covered by moving object. So distance covered is an object is moving from point A to point B. So from point A to point B it is AB, which is 5 kilometer. Then from point B to point C. So from B to C 3 kilometer. So BC it is 3 kilometer. So the distance is 5 AB plus BC. That is 5 plus 3. 8 kilometer. Next, we find the magnitude of the displacement. So we know that our initial point is A and C is the final point. So we know initial point is A and final point is B. So displacement is the shortest distance. So we find the magnitude by drawing a diagonal from A to C. So from Pythagoras theorem, by using Pythagoras theorem, we find the magnitude of AC. So by using from Pythagoras theorem, what does Pythagoras theorem tells? AC square is equal to AB square plus BC square. The square of the hypotenuse is always equal to the sum of the other two sides. Correct? So what is AC square? We don't know. But we know what is AB. AB is 5. So 5 square plus BC is 3 square, which is equal to AC square is equal to 5 square is 25 plus 3 square is 9. AC square is 25 plus 9 is 34. So AC is equal to root of 34. Root 34. Okay, let's run through a quick recap of this problem. So here we have to find the distance from A to B, from B to C. So the distance covered by the moving object is from A to B traveled 5 and from B to C it is 3. So distance traveled is 8 kilometers. Next, magnitude of displacement, wherein A is the initial point and C is the final point. So when we draw a diagonal here, by using the hypotenuse theorem, Pythagoras theorem, we find AC square is equal to AB square plus BC square. So AB is 5 kilometers and BC is 3 kilometers. When we substitute the value